What I hope to do in this video is get familiar with the notion of an interval and also think about ways that we can show an interval or interval notation. So right over here I have a number line. Now let's say I wanted to talk about the interval on the number line that goes from, let's say, from -3 to 2. So I care about this. Let me do this in a different color. Let's say I care about this interval right over here. So I care about all of the numbers from -3 to 2. So in order to be more precise, I have to be clear. Am I including -3 and 2, or am I not including -3 and 2? Or maybe I'm just including one of them. So if I'm including -3 and 2, then I would fill them in. So this right over here, I'm filling -3 and 2 in, which means that -3 and 2 are part of this interval. And when you include the endpoints, this is called a closed interval. Closed interval. Closed interval. And I just showed you how I can depict it on a number line by actually filling in the endpoints. And there's multiple ways to talk about this interval mathematically. I could say that this is all of the, let's say this number line is showing different values for x. I could say these are all of the x's that are between -3 and 2, and 2. And notice I have -3 is less than or equal to x. So that's telling us that x could be equal to -3. And then we have x is less than or equal to +2. So that means that x could be equal to +2. So it is a closed interval. Now another way that we could depict this closed interval is we could say, okay, we're talking about the interval between, and we could use brackets because it's a closed interval, -3 and 2. And once again, I'm using brackets here. These brackets tell us that we include, so this bracket on the left say that we include -3, and this bracket on the right says that we include +2 in our interval. Now sometimes you might see things written a little bit more mathy. You might see something like that, like x is a member of the real numbers such that. So, and I could put these curly brackets around like this. These curly brackets say that we're talking about a set of values, and we're saying the set of all x's that are a member of the real numbers. So this is just fancy math notation. It's a member of the real numbers. I'm using the Greek letter epsilon right over here to say member of the real numbers such that this vertical line here means such that -3 is less than x is less than, or -3 is less than or equal to x is less than or equal to 2. I could also write it this way. I could write x is a member of the real numbers such that x is a member of this closed set. I'm including the endpoints here. So these are all different ways of denoting or depicting the same interval. But let's do some more examples here. So let me draw a number line again. So number line. And now let me just do an open interval. An open interval just so that we clearly can see the difference. So let's say that I want to talk about the values between -1 and 4. Let me do this in a different color. So the values between -1 and 4, but I don't want to include -1 and 4. So this is going to be an open interval. So I'm not going to include 4, and I'm not going to include -1. Notice I have open circles here. Over here I had closed circles. The closed circles told me that I included -3 and 2. Now I have open circles here. So that says that I'm not. It's all the values in between -1 and 4. So -1 or -0.9999999 is going to be included, but -1 is not going to be included. And 3.9999999 is going to be included, but 4 is not going to be included. So what would be the notation for this? Well, here we could say x is going to be a member of the real numbers such that -1, I'm not going to say less than or equal to because x can't be equal to -1. So -1 is strictly less than x is strictly less than 4. Notice, not less than or equal because I can't be equal to 4. 4 is not included. So that's one way to say it. Or another way, I could write it like this. X is a member of the real numbers such that x is a member of, now the interval is from -1 to 4, but I'm not going to use these brackets. These brackets say, hey, let me include the endpoints, but I'm not going to include them. So I'm going to put the parentheses right over here. Parentheses. So this tells us that we're dealing with an open interval. So this right over here, let me make it clear. This is an open interval. Now you're probably wondering, okay, in this case, both endpoints were included. It's a closed interval. In this case, both endpoints were excluded. It's an open interval. Can you have things that have one endpoint included and one endpoint excluded? And the answer is absolutely. Let's see an example of that. So I'll get another number line here. Another number line. And let's say that we want to, and actually let me do it the other way around. Let me write it first, and then I'll graph it. So let's say we're thinking about all of the x's that are a member of the real numbers such that, let's say -4, let's say -4 is not included, is less than x, is less than or equal to -1. So now -1 is included. So we're not going to include -4. -4 is strictly less than, not less than or equal to. So x can't be equal to -4, so open circle there. But x could be equal to -1. It has to be less than or equal to -1. So it could be equal to -1, so I'm going to fill that in right over there. And then it's everything in between. If I want to write it with this notation, I could write x is a member of the real numbers such that x is a member of the interval. So it's going to go between -4 and -1. But we're not including -4. We have an open circle here, so I'm going to put a parentheses on that side. But we are including -1. We are including -1. So we put a bracket on that side. And so that would be, that right over there would be the notation. Now there's other things that you could do with interval notation. You could say, well, hey, everything except for some value. So let me give another example of, let's get another example here. Let's say that we want to talk about all the real numbers except for 1. So we want to include all of the real numbers, except for 1. Except for 1. So we're going to exclude 1 right over here. So open circle, but it can be any other real number. So how would we denote this? Well, we could write x is a member of the real numbers such that x does not equal 1. So here I'm saying, look, x can be a member of the real numbers, but x cannot be equal to 1. It can be anything else, but it cannot be equal to 1. And there's other ways of denoting this exact same interval. You could say x is a member of the real numbers such that x is, x is less than 1 or x is greater than 1. So you could write it just like that. Or you could do something interesting. This is the one that I would use. This is the shortest, and it makes it very clear. You're saying, hey, everything except for 1. But you can even do something fancy, like you could say x is a member of the real numbers such that x is a member of the set going from -infinity to 1, not including 1, or x is a member of the set going from, or a member of the interval going from 1, not including 1, all the way to positive infinity. And when you're talking about -infinity or positive infinity, you always put a parentheses, and the view there is you can never include everything all the way up to infinity. It needs to be at least open at that endpoint, because infinity just keeps going on and on. So you always want to put a parentheses if you're talking about infinity or negative infinity. It's not really an endpoint. It keeps going on and on forever. So you use the notation for open interval, at least at that end. And notice we're not including 1 either. So if x is a member of this interval or that interval, it essentially can be anything other than 1. But this would have been the simplest notation to describe that.